Okay, I hope you all can see just this little reading view. All right. I hope you can see the PowerPoint presentation that I have up here. Thank you all for coming. This is a meeting of Pi and AI. Pi and AI is a series created by Dr. Andrew Ng, Professor Andrew Ng of DeepLearning.AI. And there are Pi and AI meetings all across the world, getting out the word about AI, the meeting place for people to discuss AI, and DeSales University is in partnership with him. Unfortunately, in the COVID world, we can't get together physically and offer you Pis, but that's the idea behind this, and we hope that in the future we will be able to do this. So it will take some time. Our session for today is AI in the Spanish-speaking world, and I suppose I should say buenas tardes a todos, and that's about all the Spanish I'll probably try. Because we have a very interesting audience of those who registered. About half are students, but we have people dropping in from all around the globe, all parts of the globe, maybe as many as 97. And so we'll have 4 speakers who are closely associated in their Spanish heritage, and we hope to learn a lot about that in this session. My name is Brennan Pursell. I work at DeSales University. All right, so that's me, Brennan Pursell. I also lead, in addition to being a professor, I lead the program in applied AI that we're doing here at DeSales. And we have, as I mentioned, a relationship, a partnership with DeepLearning.AI. And this is the title of my book called Outsmarting AI that just came out this summer. And that is not a work of engineering. That's not my expertise, but it does explain the technology and gives guidelines about how best to use it in an organization. AI learning opportunities, very briefly at DeSales, we have a computer science major in data science. We have numerous majors in different fields such as business, homeland security, and nursing, and they have tracks in data analytics and applied AI. We also have undergraduate and graduate certificates with a similar grouping of degrees in this area. At DeepLearning.AI, Andrew Ng teaches a famous course called AI for Everyone. For those, there are many who have signed up to join this. Oh, I'm sorry, let's see. I'm sorry, I have to interrupt because Danielle, our first speaker, he's trying to get in, but he says he can't. All right, that's interesting. I'm sorry, please excuse me. Let me go to remote control. I sent him the same one that I sent to you, Juan, and to the others. Let me copy the invitation and let me send it from this program. I'm sorry about this, but we need to have all of our speakers here. Okay. All right, there we go. So that's going off to him. Very good. Okay, so back to DeepLearning.AI, and excuse me, I'll be looking at monitoring my phone and the email on the other screen just to make sure Danielle can join us. At DeepLearning.AI, there are courses for those of you who know nothing about AI or total beginners, and there are also a series of specializations, one in deep learning that's sponsored on Coursera, that's the platform. There's other specializations such as natural language processing, which is artificial intelligence applied to language, human language. There's also specializations in TensorFlow, which is developed by Google. It's a Google library for these things. And the brand new one is generative adversarial networks, which is the technology, you could say, behind some of the deep fakes that we're encountering more and more. Just by attending this session today, you will receive at the end of the session a survey. If you would please fill that out, that would offer important feedback to us. Thank you. And then a discount if you wanted to take any of the courses at DeepLearning.AI. They are very cheap. All right, let's go over here. We'll be back. Some of the latest news, just a couple minutes about the latest news about what's going on in artificial intelligence. It's such a lively field. Andrew Ng's line is, AI is the new electricity. And what he means by that isn't that it's a source of energy and power, but it seems to be a new technology that's following a similar trajectory. Not in the sense that it shows up and changes everything immediately, but it takes some time to develop, and then it spreads, as electricity did, all across every sector of the economy and every area of the world. And so it really looks like AI is doing that. It's getting better, more effective. There are more tasks that it can do. A number of people have asked me, what's AI been doing in the fight against COVID? Well, this is actually kind of instructive. We should look at this. I'm just checking to make sure Danielle can get in. Okay. So in the fight against COVID, what we're seeing is that pretty much nothing has been done in vaccine development, but that makes perfect sense because vaccine development is a wildly complicated, it's probably one of the most difficult things you can do in medicine. The systems and the mechanics, you could say, of the human immune system are mysterious, and the disease is new, so data is lacking. So, but that being said, AI tools, they include a research article search engine, gene sequencing tools. There's others that do data crunching in order to identify drugs that might improve some of the treatments for people who get COVID, just by matching the data. There are also solutions where you have thermal imaging to scan crowds and look for people with fever. And in China, apparently they're combining that with facial recognition so that they can pick people out and find them who might be carrying it and not even know that they have a symptom like a fever. Of course, with traditions of privacy in the United States, I doubt we'll be seeing that anytime soon. There are AI solutions that pick out pneumonia. They detect it in CT scans of patients' lungs. There's also AI at work in some of the contact tracing applications. And then there's this really interesting AI application out there where they're trying to predict and track where the virus is spreading by sending spiders out through the web, and especially processing the language used, language from officials and from healthcare systems, to find out, are they using the kinds of words and phrases that indicate that they're dealing with something very close to COVID. So AI is helping. It's being used in the fight against COVID. Next slide. Right. The big news these days is NLP, natural language processing, especially GPT-3. There's this association, it's essentially a research lab called OpenAI, founded by the famous Elon Musk and supported with $1 billion from Microsoft and other donors. And GPT-3 is this NLP, this natural language processing tool. It uses AI deep learning algorithms. And for this number, for those of you who have no idea what this means, 175 billion parameters. So parameter is just a number. And what this system does is it uses these 175 billion parameters, think of them as settings, in order to, shall we say, analyze texts and then generate text out of those examples. GPT-3 can produce full emails, memos, blogs, tweets, computer code, and translations. My little book that I published, if you just do the math, if you divided my number of words by the 175 billion, if you divide the number of billion parameters by my number of words, it comes down to about, for every word I wrote, GPT-3 has about 1 million parameters. And those are little settings. And so, good grief, if you were to train, which they have, trained GPT-3 on many books in English, and then many of their Spanish translations, it has been said that GPT-3 can translate an entire book at one go, which is extraordinary. This doesn't mean it's free of errors, but it gives you an idea about what natural language processing with a very powerful tool can do. Not to be outdone, Microsoft has enhanced its Deep Speed, which is a library for the PyTorch deep learning framework. Again, that's another AI system, you could say, for those of you who don't know about this. And they are now training 1 trillion parameters. So the numbers are going berserk. It's a bit like the race to build the tallest building in the world, but it's going much faster. And then on the hardware side of things, NVIDIA, which produces the world's, it's the #1 producer of GPUs And these are hard pieces of hardware that really help immensely to process, to do the legwork of AI algorithms. It's buying a company from the UK called ARM, apparently whose energy efficient chips are in about 95% of all smartphones. And if this sale goes through, the mergers are hard to do, but if this happens, it could be we'll see a lot more artificial intelligence, data analytics, and applied tasks in IoT, in the Internet of Things, in many devices, in sensors, in just simple household items. If you happen to have an Alexa at home, that already uses it. The point is, this is spreading. It's spreading faster than electricity did. Now we come to our main theme today. Why are we looking at AI in the Spanish-speaking world? Well, we have to emphasize that AI is not just an Anglo, meaning an English-speaking cultural technological project, or just confined to Anglo and Chinese areas. I just want to put some things out here for you. There is a full English-Spanish dictionary of technical terms pertaining to artificial intelligence, and you can just get it from GitHub. GitHub, the repository, the code repository where developers can share their code. And one of the earlier successes in kind of the development of AI-powered customer service systems was performed by the Spanish telecom giant Telefonica, a system called Aura, and our guest Daniel Tapias had a lot to do with that. And Aura works today in Spain, Colombia, Ecuador, Argentina, Chile, but also Brazil, and the UK and Germany. There's a nexus, there's a connection very strong between the United States and then I say Latin America. Of course, Latin America, what do we mean by that? North America includes Mexico, of course, and then there's the Central American countries, almost all Spanish speaking, and then there's the Southern American countries with also Brazil, which is Portuguese speaking, and then including the Caribbean. The network access point of the Americas, it's called NAP. It's in Miami. And through that access point in Miami, 90% of the Latin American internet and telecom data flows through there. So there's kind of a hardware nexus between the countries, and I don't think it's going to go away anytime soon, although things are changing fast. Just a couple of little data points about how quickly internet usage is growing in Latin America. In 2019, they reached nearly 500 million internet users, and internet penetration ranges 60 to 72%. Colombia we have a couple guests in Colombia today, and they've reached the population of 50 million people. Of them, 36 million are on the internet, and apparently that was a 20% rise in just 2 years. So this is spreading very quickly, and there are surveys put out, and they say that 80% of all large businesses in Latin America are using AI, of the large businesses, and they project that within a couple of years, AI applications will be implemented in 20 to 40% of all business processes. Now, I don't want to dig into this, but they are emphasizing that the trajectory of growth is headed upwards. And now, I'd like to turn and introduce our 4 speakers today. We have a very senior AI data scientist, a founder and CEO of Sigma AI, Daniel Tapias, and we have other guests at various stages in their careers, and then we have Lucas Acosta-Morales, a DeSales University computer science major. And I'm so glad they're here, and I just asked them if they could share their story and their work and what they're doing now and how they got there. So let's see, let me then stop sharing. Well, let me see, let's put this aside. Let's go over here. Stop the share, excuse me. I just want to find you, Danielle, in the full list of people. There you are, Danielle. And I've now made you a co-host. Danielle, if you have any slides you would like to show. Otherwise, Danielle, please, why don't you take the floor, if you would be so kind, Danielle, and introduce yourself and tell us about Sigma AI, tell us about your work, tell us about your journey into AI. I'm looking for you, Danielle. I see you on the list. Let me unmute you. There you are. Sir.
Hello?
Hello, yes, we can hear you. Excellent.
Okay, perfect.
Thank you for joining us.
No, thank you very much for inviting me, Brennan. For me, it's a great opportunity and to be able to share some of my experiences in this interesting roundtable. So, hope that all the things that I say, or most of them, can be useful for the audience. So thank you very much for inviting me. I would say that I didn't come into AI directly, so when I started studying electrical engineering back in 1980s, it was a long time ago. My main interest was electronics, right? So the idea of understanding how electronics were able to transfer signals and do amazing things like the TV or computers was my main area of interest. However, when I was in the third year was when I discovered that it wasn't not the right fit for me. Because I discovered a thing which was more amazing than that for me. Okay, I'm talking from my perspective, which was the digital signal processing. Because what electronics does is to basically implement algorithms that allow you to transfer signals and be able to process this information and extract something which is useful for many different purposes. So the idea of understanding the mathematics that are behind it and see how you can process signals, extract information, and make it useful was something that, it was like very motivating and challenging for me. So then I was lucky in the sense that I had the chance of working in a very interesting project at the time, which was building one of the first speech recognizers in the world, working in car environmental conditions, which, as you know, are very noisy. And if you think of the cars that we had in 1980, these cars were very much noisier than they are now. So it was a real challenge. The technology was limited. The cars were more noisier. And I discovered that speech signal is something, probably one of the most complex signals you can find. Because if you collect data, you record speech from many different people, let's say 1,000 people, and everyone say the same sentence, and then you look at the signal, you don't see two signals which are equal, So it's amazing how the brain is able to map different signals into the same message, right? Mm-hmm. And I say, well, this is so challenging that I want to make something that is able, some algorithm which is able to understand or to at least transcribe what human beings are saying. So that was my start. It was at the end of the 1980s. I had a chance of working with many, the most advanced centers in the world at the time. So was lucky also in that sense. So many times in your life, you have to make choices, but you have to be also lucky and have the chance of making the right choices. And I was lucky in the sense that I was able to collaborate, for example, with the AT&T Bell Labs here in the States at the beginning of the 90s, which was the most advanced by far center in the world working in speech technologies, also with Carnegie Mellon University in the mid 90s. So a couple of things with MIT, so I was, working from Madrid, but in many international projects, which allowed me to see different ways of approaching the same problem, different cultures and ways of, analyzing that and facing different challenges. So that was for me really a game changer at the time. And that made me focus more in research and development, which I did for about 20 years. And then in 2008, I decided to create my company. The reason why I did it is because I had also the chance of not only developing the technology in the Research and Development Center of Telefonica, as you mentioned before, and putting the seed of what now is the Aura system. But also I was able to work in product development, deployment of solutions in the, internationally, and see what is the difference between something that you develop in the lab and something that you have to put in real world conditions and it has to work properly, right? So knowing on this, all the different pieces of this path allow you to see the, to have a global view and see how you can improve the whole process. And that's why I decided to create the company in 2008. So trying to put all together and make things in a little bit in a different way, which I think is better. And we have like three different things that I think that are useful for this, round table in the way we approach AI. The three things are the following. First thing is that AI has two main components. One is data, The other component is are the algorithms themselves, right? So you have to have state-of-the-art algorithms which allow you to get as much as you can from data, but also you need to have the right examples. AI learns from examples. It's like children, right? So if children do not have the right examples, they don't learn properly. The same thing happens with AI. So having the right data with the right quality, that is critical when it comes to have something that works. So we decided to have both things in the same company, being able to control the quality of the data and at the same time developing the algorithms by ourselves so we have the best we can have. And when we combine both, we have the maximum, accuracy possible. The second thing is that, AI has to be adapted to the use case. You need to adapt the technology to each use case because the environmental conditions, the type of users, all these things change. And there is no a general solution that is able to cope with any type of situation. So the best thing to do is to collect data from their use case and adapt the algorithms quickly. But that has to be quickly because otherwise it takes forever. So we have developed algorithms which allow us to adapt the technology really quick and easy to any new environment. And the third thing which differentiates us from many other companies working in the field is that we combine many different sources of information. We try to imitate human beings. So humans do not make decisions based in one source of information. We usually get different sources of information, combine all of them, and then we make a decision. So the idea of the company is that we're able to combine different sources. So be it text, audio, video, images, or biometric data. And by combining all of these things, being able to resolve, complex challenges in the real world. So this is basically the summary of the whole story of my professional career.
Super, thank you, Dania.
Sure.
Especially your third point that you're making about the importance of combining many sources of information to make sure that the application works. Juan, Vazquez, that reminds me of the work that you're doing there at PP&L about all the information, all the data that this large power company can do, has at access, and then bring it together and then derive insights from that, actionable insights and systems. Is that a fair comparison?
That's a fair comparison. Well, hi everyone. My name is Juan. So it's a pleasure to be here with you and to be talking about these topics. I totally agree with Daniel, Brennan. So having that data source and the variety of data is key for any algorithm. Mm-hmm. So I prepared a few slides to talk about my journey. So I'm hoping that the audience enjoy what I have prepared. Mm-hmm. Let me know if I can share my screen.
Yeah, you should be able to.
Okay, perfect. Oh, yes, sorry. All right, so.
Yep, we can see that.
Okay, so let's talk a little bit about me. So I come from Puerto Rico, which is a territory in the United States. My background is a little bit different because I do not come from a data science pedigree. I come from more of an engineering background. I did my bachelor and master's in mechanical engineering, and I work 15 years in aerospace and energy. I'm currently working here in the Lehigh Valley, very close to DeSales University. And I work there as a senior data scientist. So in my role, I get to play with data and I get to develop some cool algorithms to solve different problems. I have a passion for cloud computing and the application of machine learning, especially in the cloud. And then mostly, at least in my company, we are working with Microsoft Azure. And that's kind of the platform that we are working on. And as you guys work in the field, I will say that programming is a big part of data science overall. So these are some of the languages that I use. So I started with R, like almost everybody else on academia, but then I developed over the years some expertise in different languages. So it's really key to at least dominate a few, and then that will help you on your journey. So I come from Puerto Rico. So Puerto Rico is part of the US, it's not in Latin America, but it's mostly Spanish speaking people. We have about 3 million US citizens there, and it's very close to the mainland. It's about 2.5 hour flight to Florida. And then I will say to New York is about 5 hours and a half. So it's not that far. And the good thing about being raised in Puerto Rico is that they had really good engineering schools, and the country is big on math and science. Although they do not have a lot of data scientists and data science programs at the time I studied. So I went through engineering because I really enjoy math and statistics. And then I was fortunate enough to get to work there in the island. All right, so my first job in the island was to work for UTC, basically working for military and commercial aircraft systems. It was in an electronics manufacturing facility, so we were building a lot of cool controls for the aircraft. And then there, I rediscovered after studying in college my passion for statistics, because I can remember back in the early 2000s, there was a focus on defect reduction, and they brought Six Sigma. So to me, having that knowledge about statistics made me a really powerful engineer. And then eventually that brought me into the data science field. Then after I worked for a few years in Puerto Rico, I decided to come to the mainland. And I moved to a company in Connecticut where we were building helicopters for the military. And I worked there as a Six Sigma black belt, working to solve many problems with the processes, doing more of a process optimization, statistical analysis, and I was learning a lot. I always kept, since working on my first job, using my statistics, because when you analyze things with data and you bring data into the table, you can create really powerful solutions. But I will say after a decade there, I moved to the Lehigh Valley area. And then here is where I transitioned from an engineer that knew about stats into a data scientist and machine learning kind of role. So I work right now for an electric utility. So basically we have a lot of equipment in our territory to do transmission and distribution of electricity. And something I do there, like I use AI and machine learning to solve different business problems and engineering problems. In terms of, you know, we have lines, we have a lot of equipment, and then we are working to make sure that we have algorithms to help us improve on reliability. Also customer service and metering, because we need to collect some revenue. I love coaching the employees in statistical methods, machine learning, cloud computing, data engineering, and using dashboards, because I think besides data, which is the engine for any machine learning algorithm, I think having good visualizations is key, because at the end of the day, you need to present those results to your business partners. And additionally, I'm a grad school professor in a nearby university here in the Lehigh Valley. and I teach statistical modeling as well. All right, so I will say about 6 to 8 months ago, I co-founded also the Lehigh Valley Actual Users Group, and the idea of this group was to advance predictive analytics in the Lehigh Valley region here in Pennsylvania, with a focus on machine learning, AI, and data engineering, with Microsoft as the ecosystem. And then that's a group that meets and has events to bring professional networking and bring top industry speakers so that we raise awareness and a community of AI and machine learning. So if you have, if you want to connect with me, you can connect on LinkedIn, Juan Vazquez. And then if there's any questions, I can take questions now if you have any.
Thank you, Juan, very much. Danielle, can we move this back to you briefly? I'm wondering if some of our viewers are thinking, boy, it sounds like speech recognition, what Danielle does is so different from the statistical analysis and the predictive analytics that Juan is doing. Is that the case? Is it just for our viewers, Danielle, is that the case or not the case?
Well, yeah, I think that AI can be, as you said in your introduction, which was really very comprehensive, AI can be applied to many different things. So speech would be one of the areas where what you are trying to do is to see if you can map different waveforms, the shape of the waves, into a specific, let's say, sounds, and then you can group sounds to form words, and from words you make sentences. So basically, speech recognition tries to combine, on the one hand, acoustic analytics, so you're analyzing the acoustics of the signals together with linguistic knowledge. So it's a different way of applying AI to a specific problem, which is speech recognition. So basically the thing is that AI basically is about machine learning, right? Yes. So machines can learn about many different things. In the case of speech recognition, what we're trying to teach to the algorithms is basically how to interpret signals and how to combine this interpretation together with linguistic knowledge about the language, right? Yeah. Well, for example, when you're doing statistical analytics, what you're trying to do is to see whether the data that you have allows you to predict, for example, the future or the behavior, all those things, or analyze, the previous behaviors and extract information out of things that had happened already. So it's a different way of applying machine learning, right? Just to give an idea of the different things that you can do. For example, we're working now in projects we have nothing to do with speech recognition that are completely different in terms of extracting patterns out of data, because machine learning in the end is trying to classify the data that we receive into different pieces of information that we can later interpret and use for different purposes, right? Yes. So in the end, machine learning, we can see it as a huge classifier that allows us to classify information and extract, useful data out of it, right? So then you can apply it to many different things.
Thank you, Danielle. Just to highlight this, think of it, folks, as a classifier. We have sound waves, digitized versions. This is digital readings. We're trying to map it to words that people understand. So Camilo, can we turn to you and David? They're in Bearing.ai. You're in Medellin, Colombia. Classifiers, machine learning, AI, statistical relationships. Take over. What are you doing there at your entity in Colombia that matches what Danielle and Juan have described to us?
Okay, so before David, before talking about Bearing,
sure.
I wanted to talk because I was working before entering Bearing in a small startup. We were doing chatbots, and well, I trained and deployed like a speech synthesis models. So we were doing it what Danielle was doing, but backwards.
Yeah.
From text, we were generating the audio with different accents and
that's brilliant.
regions. Yes, so we were doing like the inverse problem.
So it goes one way to the other.
Yes, we were doing it backwards. And well, after Vosi, this startup was called Vosi, and I entered Bearing. And if David could, if you want to speak a little bit.
Yeah.
Mm-hmm.
Yeah, sure. Thanks. Yeah. So, hey guys, my name is David. I'm the technical co-founder of Bearing.ai. So we're a very early stage startup doing machine learnings for the shipping industry. So what we're trying to do is we're trying to revolutionize the shipping industry with AI. More specifically, our first few products is trying to improve the operational efficiencies, more particular in the amount of fuel consumptions for different cross-ocean voyages in maritime transportation. So we're basically bring AI algorithm into their day-to-day operation and come up with the most efficient recommendations for a shipping crew to control their voyage, to pick their routes, and then to pick their RPM speed profile. And a little bit more about Bearing. We are a Palo Alto-based startup. We are part of the AI fund ecosystem, which is led by Professor Andrew Ng. We're one of Andrew's multiple startups. And so our mission as AI fund in general is trying to make AI the next electricity. We're really trying to apply AI to all areas of the world and try to revolutionize the world as what the electricity has done 100 years ago. And another part of AI Fund's mission is that we believe that Latin America can have one of the AI innovation centers like Palo Alto or Beijing. And furthermore, we believe Medellin, Colombia is the place. So we have so far invested heavily in building engineering infrastructure from day one.
Why is that, David? Tell us why Medellin, why Colombia, please.
Oh, so why Colombia? Besides the perfect weather and nice people, great coffee. Also, there's a lot of talented people. And also, I think this is what I heard. I think we had the government of Colombia was supporting our mission. And also we have a much easier sort of a process of establishing our company there and doing the hiring. Right. And also it's just more centered in sort of in Latin America. And so we can chat with, I heard different rumors of why Colombia is the first place, but I'll probably have to talk to Andrew, get a absolute clear answer. But so far we have seen
there's a lively community and it's really taking off.
Absolutely, yeah. And I recently just was in one of the PyCon in Colombia. I've seen a lot of interesting technologies was discussed in the conference. So I don't think it's particularly will be in Colombia. I think all countries in Latin America will rise very, very soon in terms of picking up this baton of AI, of this innovation trend. But it just happened that we are in Colombia first at the moment. Right. So yeah, and Bearing in particular, we're the company of the AI fund that we exclusively hired in Colombia. So my first employee in my company was in Colombia, and I now have grown an entire team in there. So I have no real engineer teams in Palo Alto at the moment. And so far has been working out great, even given the whole COVID pandemic situation. We're able to keep the momentum going. We're able to deliver great products. So I'm very, very impressed with the talent in Medellin.
So excellent. Yeah. So with Danielle and Juan, they got into this first in engineering. Like Danielle, you started in electrical engineering and followed signal processing. And Juan, you were in mechanical engineering and quality controls. David, did you start? Could you tell us just a bit about?
Yes, so I have a similar path, right? I started out with doing electrical engineering, more focused on semiconductors, semiconductor design and fabrication. So I worked at Intel for about 10 years, working on various stages of building microprocessors. And I also had an opportunity to run a team in Costa Rica to do high volume manufacturing of CPU chips. So I had quite a bit of experience working in Latin America. And also some of my lifelong friends from college They're all from Peru, from Colombia and Costa Rica. So yeah, I have a very strong tie with Latin America, with the Spanish-speaking world. So, and after a 10-year stint in Intel, I decided to go back to study computer science more seriously. So I switched from electrical engineer to computer science, more specifically in machine learning. So I went back and got another master's degree in computer science, focusing on machine learning, and that's where I met Andrew. And then he was a great source of inspiration for me. And after I completed my training in machine learning, I first started out working on projects in Intel, trying to optimizing our production flow with machine learning. And then I decided, since I'm in Silicon Valley for quite a bit of time already, startup is where everything's at. So I joined my first startup. It's called Moveworks. I was there for about 2 years, and we grew the company from 15 people to 200 in about 2 years. And then after that, yeah, so we were doing, coincidentally, we were doing NLP as well. So we're building chatbots, conversational chatbots. So we're doing, all kind of word vectors, doing sentence embeddings, doing conversational flows. So yeah, I'm pretty familiar with the language aspect of machine learning. So after my 2-year stay in Moveworks, so I was essentially approached by Andrew to be a co-founder of this new company called Bearing. So this is a very interesting project because unlike the traditional approach where we take a CNN or RNN or a transformer model, which is the newest and fanciest model in the world of computer vision and NLP, we take those and then we try to accelerate that and build something really, really advanced, really, really cool. In Bearing, we took a step back. We're looking at what are the industries that are now as technical advanced or as technical ready as some of the really advanced industry, and how can we apply machine learning in those industries. And shipping was one of the industries we see there's a tremendous amount of opportunity, where 70% of the overall cost in the shipping industry is in energy consumption. And 70%. There's almost no 70%, yeah. I think it's more, well, given the current condition of the world, right, given the COVID condition, it's probably less. But once we recover back to normal, it will be 70% or more in the overall operation is energy. And then there is no, and today the fundamental approach in the shipping industry is captain's intuition. How do I operate a ship? Or which route do I take? It's purely based on experience and based on intuition, and it's average based. So we think, okay, last 10 years,
of the
roughly,
captain.
Yes, yeah. It's you'd be amazed how many industries are still using Windows 97.
And driven by the guts and not by the data.
Yes. Yeah, not by the data, and yeah. So that was it's a great opportunity. We see a great opportunity, and then so we spent about a year now on trying to break into this industry and trying to essentially create a market and build a product. And yeah, so that's where we are right now. We have released our first a few products and got some great feedbacks from a customer, and we're looking forward to build a great company and revolutionize one of the many industries that can be revolutionized by AI.
Excellent, David. We wish you luck with that. And Camilo, how do we say, of the professionals, you're the newest. Did you go directly into mathematics statistics with the aim of going into AI? Or did you first study something else and then go into AI?
I completely pivoted. So I started studying like business management engineering.
Business management engineering, okay.
That's like a career we have here in Colombia. Yeah. And it was very oriented to the statistics part. Yeah, yes. So I worked with time series analysis, the autoregressive moving averages. But then I was very interested in physics. So I started studying physics and went into general relativity and string theory. And well, studying that, I wanted to do some projects with AI. So we published a paper with gravitational waves and machine learning. And I started working in that area. I also had a little bit of experience in business intelligence.
Mm-hmm.
So I really like that part. But then, yeah, I pivoted completely. I started working in Vosi and currently in Bearing. Yeah, but that wasn't my initial aim.
Mm-hmm. But you found an opportunity and you pursued it.
Yes.
And are you enjoying it? Because I mean, is it fundamentally different from what you were doing before? No, it is data analytics. It is
It's
predictive.
very similar, yeah, because when I was working in business intelligence, I was optimizing but truck routes.
Yes.
So we had like a big company here in Colombia that they build like concrete and very construction equipment, and we were optimizing their routes, but we were not using any machine learning. So it's very cool to, yeah, like this is another level at Bearing. Yeah, we are using machine learning to optimize everything.
That's excellent.
Yeah, so it's been quite a ride.
Super. Thank you very much. And now Lucas, welcome Lucas. Lucas is the youngest of our guests, and he is a student at DeSales University. And Lucas, you are a data science track student. You are probably the most direct headed towards AI of everyone here, but you have a presentation that you are that you'd like to share with people. This is undergrad level, right? But this is not industry level, but you are using machine learning to sort out a Japanese game. Would you like to take over and share with us what you've been working on using a very accessible piece of hardware called the Raspberry Pi?
Sure, let me just share my screen.
Looks great. Fire away.
All right. Mathematical and logic puzzles are always a great way to have fun while stimulating one's critical thinking skills. From a mathematician's perspective, a study of these puzzles could lead to a better understanding of patterns in shapes, numbers, and colors. For a computer scientist, these puzzles present unique opportunities to compare the power of a human's reasoning to that of a computer. This summer, under the guidance of Dr. Kathleen Ryan, I conducted research into the double choco puzzle and the possible ways to solve it. The goal of our project was to solve a variant of the double choco puzzle, which we have called the double vanilla puzzle. We then aimed to implement our solution in a small game application. A double choco puzzle's main component involves dividing a grid of tiles into shapes that adhere to certain rules. The standard double choco grid is divided evenly into gray and white tiles. A solved grid is shown here. When dividing the grid, it is important that each shape created also has an even split between gray and white tiles. The rules also state that the colors within a shape must exhibit symmetry. For example, take a look at the shape outlined in the red with the number 5 in it. There are exactly 5 gray and 5 white tiles inside the shape, matching the number 5 also contained within the shape. If you take a closer look, you will notice that both the white and gray tiles form an L shape. This is what is meant by symmetry. The tiles are arranged almost identically, although one set of tiles has been rotated to fit nicely into the grid with the other set of tiles. I will now solve an example puzzle for demonstration. A human-created grid like this one will often have a starting point. Here, the tile in the top right corner serves as this starting point. According to the rules, the number 1 in the tile means that the shape created using that tile can only have 1 tile of each color, so 1 white and 1 gray. This forces us to connect it with the only white tile, which is to the right of it. Continuing on to the right, this grouping of 3 gray tiles with the 2 number 3s in them will serve as our second shape. To know which 3 white tiles to select, we use the shape of the gray tiles as an indicator. The 3 gray tiles form an L shape, meaning that the corresponding white tiles must also have a similar shape due to the symmetry rule. The rules allow for the shape to be rotated as long as the 2 groups are adjacent, so the grouping of white tiles directly to the left, being these 3 here, will work when connected with the gray tiles. At this point, the gray tile below the one where we started is isolated all by itself. Because it does not have a number, this means that we must decide the value. Because there are no other gray tiles available, we can assume it to be a 1 and connect it with the singular white tile directly below as so. Applying the same logic to the white tile in the bottom left corner, we can connect it to the singular gray tile to the right of it. We now just need to verify that this final shape here with the number 2 is in fact valid according to the rules. And so we see 2 white tiles and 2 gray tiles, which are both in straight lines, so they exhibit symmetry, which means that the shape is valid and the puzzle is solved. Our project uses a custom variant, the double vanilla puzzle. The main difference between the double choco puzzle I just solved and a double vanilla puzzle is that all the numbers have been left blank for simplicity. For reference, the puzzle I solved in the last slide would now look something like this. Our first attempt at solving puzzles was the deterministic approach. A deterministic algorithm essentially uses code to tell the computer the exact steps to create and solve a puzzle successfully every time. Although it is very effective, it is not very efficient and only works on small cases. This is because the only known approach to solving these puzzles without human intuition about how to group tiles is a brute force approach that tries every possible way to draw the borders on the grid. At this time, our deterministic application looks something like this. Users can click on the borders to solve the puzzle and then view the correct solution to compare with their answers. Our second attempt at solving these puzzles was using a machine learning approach. Unlike the deterministic approach, machine learning does not tell the computer how to solve a particular problem, but rather lets the computer analyze the problem and figure out how to solve it on its own. In the case of our project, this meant using the data we collected from our deterministic algorithm to find patterns and make predictions about how to solve future puzzles. The specific machine learning code used for this project is based off a similar endeavor to have a machine learning process solve Sudoku grids. For these grids to be read as data, they had to be converted into something the computer could interpret. As seen in this example, the Sudoku solver turned a grid into a string of numbers, with each number representing one square in the grid and empty tiles being represented as zeros. The full Sudoku project used a data set of 1 million puzzles and looks like this. The full code creates a model using this data and then uses the model when calculating predictions on future puzzles. This is a sample input puzzle followed by the Sudoku model's prediction. The grid is solved by having the machine learning model predict the value in each of the zeros on the grid. The Sudoku code uses a convolution neural network, or CNN, which is tailored towards training on grid-like data such as puzzle grids and images. Neural networks use layers of data points called neurons that emulate those of the human brain to produce a similar learning process. Further investigation is being done into how a CNN works and how it can be optimized specifically for double choco data. The following is an example of what a neural network might look like. Data is inputted on the left in a series of nodes. In the Sudoku case, each individual tile serves as one of these nodes. The data is then sent through multiple hidden layers of equations. During each hidden layer, weights are essentially applied to the input data in such a way that maximizes the percentage of correct output data. After all the weights have been applied by all the hidden layers, the model compares its output data with the expected solution from the training set so as to estimate the model's accuracy. The model would then readjust the weights during the next training session and repeat the process until it produces a final model. Though this seems complicated, various code packages exist to help you create the model. So from a coder's perspective, the hardest part of creating a neural network is setting all the various parameters for training. It is important to select the correct number of hidden layers, how much the computer should adjust when it gets a puzzle wrong, as well as many other factors that are required to train an effective model. In the Sudoku case, an unsolved puzzle is inputted, and the model should theoretically make predictions by only filling in the blank spaces. As I mentioned, the actual functioning of the neural network is taken care of in the Keras package provided by the Python programming language. The main setup of the neural network on our part comes from setting the various customizable parameters for the model as displayed in this block of code. For example, the model input, which is circled here in green, is set to 991 because Sudoku is played on a 9x9 grid. We are currently looking into all the possible parameters used in the Sudoku code and how they work so they can be altered to fit our project. For our project, the machine learning code that has been written can load and train on the double choco puzzle data. It currently reports a 40 to 50% accuracy, which means the model is more or less guessing. While the easiest way to increase the accuracy is to increase the sample size, there is only an estimated 13,000 double choco grids of size 4x4 that are possible, meaning generating too many puzzles leads to duplicate data and a model that is too tailored to the data, something common with the CNN approach. One of our biggest challenges in optimizing the Sudoku code is the encoding process. In Sudoku, each tile on the grid contains one singular piece of information, being the number on the tile. For our puzzle, we must keep track of a tile's color and information on all four borders surrounding the tile. We are currently investigating various encodings to determine the one that will work best with the model. Going forward, the project has a clear goal for each of our approaches to solving this problem. On the deterministic side, it is important to decrease the time it takes to generate puzzles and expand compatibility with larger cases. On the machine learning side, it is pertinent that the accuracy of the CNN model be increased to take full advantage of the machine learning approach. While the current project does feature a fully functional application, much work is left to be done. If we are to push our minds further with math puzzles, we must first push our computers further with a more effective machine learning approach. Thank you.
Thank you, Lucas. Thank you very much. We're nearly at the time. We're nearly at the top of the hour. I'd just like to throw it open to all members of the round table. If you could, what I'm asking for, parting thoughts as it occurred to you based on the conversations and the presentation that you've partaken in so far today for our audience. What should they be looking for if they're interested in this? What would be the best next steps? Please.
So if I may, I think that one of the interesting things that we should think of when it comes to AI is that there are things for which AI is really a great alternative, and other things for which humans are really good at. So I think that one interesting approach of AI is using it for augmenting humans. So basically helping humans to do our work much better, and by doing things that machines do really well. And that today with the current technology, there are many things that technology do much better than humans. So for example, all the repetitive tasks which require a lot of computational power, and we cannot do it as humans. So that's something that technology does much better than humans. When it comes to scaling, same thing. If we want to scale something which is repetitive, technology can help us a lot in that. Or if we want to have consistency, right? If you want to do all the things in the same way, in the exact same way, technology is much better than humans. Same thing when it comes to speed, for example, or when it comes to privacy, which is something we haven't discussed here, but privacy issues are becoming more and more important. And you, Brennan, mentioned it in your introduction. That is a real, deal breaker in many cases when it comes to using the technology in many real problems. So for that, machines are really good. However, when it comes to using context information, using knowledge and experience, humans are much better than machines for the moment. I don't know what will happen in the next 50 years, but now we are much better than machines. And the same thing when it comes to adapting to new situations where, humans still are much better than machines. So I would say that a good combination, as technology evolves, a good combination of human capacities with machine capacities would give us, the key to solve many of the real problems that we have to face today.
Thank you, Daniel. Juan, in parting.
Hey, thank you. So I saw a lot of junior people on the audience. All I have to say is that as you move in your careers, remember that machine learning and the world of AI is gonna take a bigger and bigger role as GL comes. So if I was young in my career, I will start getting more familiar with AI, machine learning, and if this is an area of interest, there's plenty of resources to get yourself familiar with statistics and start your own journey.
Thank you, Juan. David.
Yes, I think I would like to add to that is be more imaginative when you approach AI. Right? Definitely, you will need more the basics, the fundamentals of mathematics, statistics, and some level programming to be able to do AI. But once you get into the world of AI, there are many opportunities that that might not be obvious, that might be hidden behind the scene. But be imaginative. AI's reach is really broad, and it can be applied in a very surprising, very unconventional way. So keep an open mind, and yeah, really try to apply this this amazing technology to as many areas as possible.
Thank you, David. Camilo.
I just want to add one more thing.
Sorry.
We are hiring. We're hiring. Yeah, so we're hiring at Bearing.ai. So if you're interested to join a startup who does AI, please look us up. Bearing.ai.
Excellent. Thank you, David. Camilo, please.
So yeah, I just want to encourage everyone that's interested in studying this. You can see that many of us didn't start it directly in AI. A lot of us just pivoted. So as Juan was saying, there's a lot of resources. So if you're interested, yeah, Bearing is hiring. There's a lot of need for machine learning engineers. So this is a there's a lot of potential. The field is growing a lot. So yeah, just start studying. Yeah, there's Andrew and G's courses. So yeah, just wanted to say that. Yeah, thanks.
Thank you. And the last word goes to you, Lucas.
I just wanted to say thank you for inviting me. It was a real honor to present here.
You are most welcome, and thank you to our guests. Thank you very much. Thank you to the attendees. We need to wind this up. If everyone could give a good virtual hand for our roundtable. Thank you, everyone doing that. Let me end sharing now. We'll end this here, and we'll go to this screen. Thank you all very much.
Brennan.
Appreciate
all
the time and investment that you put into this. Thank you very much, and everyone, take care.
Thank you.
Thank you.
Bye, everyone. Thank you for attending.
And Juan, with your permission, I believe I'd like to bring along Jake and David. Is that no, Dave? Sorry, Jake and Nick to the Lehigh Valley Azure users group, if that's all right with you.
Absolutely, yeah. We have an event coming up.